Hi everyone, welcome to another mock interview. This time the interviewer is Maliha, my own sister. But don't worry, she's never going to reveal me what the questions are before we start. Please watch the video till the end and look at the thought process, look at how I am coming up with an approach and how basically I'm discussing it with the interviewer. And guys, if you love these videos, make sure that you leave like and a small comment telling that how these videos are helping you so that I get motivation and I make more such content. Alright, watch the video till the end, look at the entire thought process, look at the entire discussion of the space and time complexities. Apart from learning the questions which have been asked in this interview, you will also learn that how you can discuss it with the interviewer, right? This is the problem which most of the people face, that they know the solution but they don't know how to express it in front of the interviewer. So that's why these mock interviews are really helpful. You can increase the speed of the video to 1.5x if you are if you can basically understand it at 1.5x, make it 1.5. If you can understand it at 2x, make it 2. All right, now let us start the interview. 1, 2, 3, start.
Hi Faraz, I'm Maliha and this is your DSA round of 45 minutes. So let's start with the first question.
Okay.
Okay, so you have been given an array of integers
All right.
and you have been given an integer k.
Mm-hmm.
So in each window of size k,
Okay.
you have to give me the largest element present.
All right. So basically, we are given an integer array. In that integer array, for every window, basically we are starting the window of size k from the first position, that is from the index 0 till the index k minus 1.
Right.
Then we will move this window ahead from the index 1 to the index k. Then from the index 2 to the index k plus 1 and so on. And in each window, we have to tell the maximum element in that window. So one obvious way to do this is basically to take a window and find the maximum in that window, then move ahead and find the maximum in that window. But then it will be of big O of n multiplied by k, where k is the size of the window. All right.
Yeah.
So yeah, but we can do better than this as well. So let's say if we have elements, let me write the example here itself. So let's say 1, 4, 3, 5, 6, 3, 4, 7, and the size of the window be equal to 3. Okay, so initially we have 1, 4, 3. In this, the maximum is 4, right?
Right.
So, all right. So in the next window, this 1 is of no use, and the maximum is 5. So what we can do is we can basically, let's say if we are just going to search for the first window. In the first window, there's 1 appearing first, then 4 is appearing after 1. So as soon as 4 comes into the picture, we don't have to use 1 anymore, because 1 is now going to be like this, not obviously the largest, because 4 has already appeared. So 1 is of no use. We can simply ignore 1, right? So from the window, I can simply remove 1. Then 4 is going to be there. Then 3 is going to be there. But because 3 is coming after 4, so we will have to keep 3. Why so? Because it might be used in the next window. For the current window, it is of no use.
Right.
But for the future, it might be of use. It might be possible that 4 is now going out, because 4 is no more in the window. So for, let's say in this window, 4 is not appearing anymore, right? In that case, 3 might be a candidate for the maximum. In this case, it is not, but there might be an example. Let's say this is the example. So in this example, this 3 is maximum for this,
Right.
right? तो यार वीडियो में आगे बढ़ने से पहले आप लोगों के लिए एक बहुत ही इंपॉर्टेंट इन्फॉर्मेशन है। तो यार ये जो टाइम है, इस टाइम पे लोगों को काफ़ी सारे अप्रेजल्स वगैरह मिल रहे होते हैं, लोग बहुत एक्साइटेड होते हैं बिकॉज दे आर गोइंग टू गेट इंक्रीमेंट. But apart from increment, people also seek that they should be getting more responsibilities, they should be growing in the organization and have more ownership of the project that they are doing. तो ये सब आपको एक स्टार्टअप में बहुत ही अच्छे से देखने को मिल जाता है. एंड स्टार्टअप में आप लोगों की जो ग्रोथ होती है ना, वो बहुत ज़्यादा होती है एज़ कम्पेयर टू अदर कंपनीज. और यार अब तो स्टार्टअप्स में जॉब पाना भी बहुत ज़्यादा आसान हो गया है. सो देयर इज़ एन ऐप बाय द नेम हायरेक्ट, जहाँ पर आप लोग डायरेक्टली स्टार्टअप के फाउंडर्स, को फाउंडर्स से इंटरेक्ट कर सकते हैं एंड अपने पसंद की, अपने प्रोफाइल के हिसाब से जॉब ले सकते हैं. आप लोगों को कुछ नहीं करना होता, आप लोगों को वहाँ पर ऐप पे जाना है, 2-3 क्वेश्चंस हैं, उनका आंसर करना है, और जो ऐप का एल्गोरिदम है वो आपको आपकी डिज़ायर्ड जॉब से मैच करा देगा. देन यू कैन इंटरेक्ट विद द रिक्रूटर्स। और इसमें जो आपकी इन्फॉर्मेशन है ना वो बिल्कुल ही प्राइवेट रहती है। ओनली इफ़ यू वांटेड टू शेयर विद सम रिक्रूटर तभी आपकी इन्फॉर्मेशन एक रिक्रूटर को दी जाती है। तो बीच में यहाँ पर कोई भी कंसल्टेंट वगैरह इन्वॉल्व नहीं है, डायरेक्ट आपकी रिक्रूटर से ही बात होती है। एंड विद द एंटायर प्रोसेस यू मैनेज टू गेट अ वेरी गुड जॉब इन वन ऑफ द स्टार्टअप। ऑलरेडी यहाँ पर 1,20,000 से ज़्यादा स्टार्टअप्स हायर कर रहे हैं एंड काफ़ी लोगों की प्लेसमेंट्स भी लग रही हैं। अब ऐप की जो लिंक है वो आपको डिस्क्रिप्शन में नीचे मिल जाएगी, आप लोग जाकर के ऐप को डाउनलोड कर सकते हैं और हाईरेक्ट के साथ अपना जो करियर है उसको हाइक कर सकते हैं। सो अपना करियर हाइक करके तो देखो। So basically what I'm thinking is basically I'm going to maintain a queue kind of structure. Okay, that queue will be such that it is going to contain the maximum element, it is going to have the maximum element at the front.
Okay.
Okay, so basically why at the front? Because all the elements which are smaller than this one, the current element will be moved out, right? It will be kind of a monotone structure. So let's say if I'm inserting 4, all the elements which are smaller than 4 and which are coming before 4 are going to be removed. They are of no use. All right.
Yeah.
In the future windows, they don't have any use.
Right. Right.
So yeah, I can maintain such a structure. So I will keep pushing elements into this particular structure and I will keep removing the elements which are smaller than the current element. Alright, so it will be kind of a decreasing structure. It will be kind of a decreasing structure. Okay. Yeah, so I can maintain this structure with the help of, so basically I have to insert something into this and then keep removing it. So basically, yeah, it might be possible with the help of a vector as well. So if I keep a vector, I can simply remove these elements from the, but then removing them from the front will be difficult if I use a vector, because I also need to remove from the front. Why? Because it might be possible that I have shifted to some newer window, right? So in that case, some elements need to be removed from this structure. So that could be done removing from the front with the help of a deck. I think deck is the structure in which we can remove from the front in big O of 1, right?
Yeah.
And Q can also help in this case. Q, inserting from the back and popping from the back is difficult inside the Q, right? So yeah, we can keep a deck.
Okay.
Okay. Yeah.
Okay. So what will be the time complexity for this solution?
So basically each element is coming inside the deck only once and then leaving the deck only once. So in the first case, like every element is going to be there in the deck, will pass through this deck. So in that case, the complexity, the space complexity would be big O of k, while the time complexity will be big O of n. Each element is passing through this particular deck.
Alright, so you can code the solution.
Alright, so we need to return the answer for every window. So we are basically returning a vector of int. And let's say max in window. Let me just put it on charge. Right. Yeah. So max in window is the name of function. We are given a vector of integer nums and size of the window. Okay. Right. So first of all, I will insert the initial k elements inside this deck structure which I am going to maintain. Okay. So deck of type int window. Okay. This will be my window. And for int I is equal to 0, I smaller than k, I plus plus, I'm basically going to insert every element inside this window using the same logic which I said, that if the current element is greater than few of the element, I will simply remove those elements. Okay, so my current element is nums of I, right? While this window is not empty, while window dot size, and in nums of I, if it is greater than window dot back, right? If it is greater than window dot back or equal to as well. equal to as well, right? So if it's greater than equal to window dot back, I will keep removing elements from the window. Pop back. Finally, at the end, I will push this element inside the window. Push back nums of I. So this way I will end up inserting all the elements. Now this is the first window, and let me make an answer here. Vector of int answer. This answer push back window dot front, the first element of the window. Right. Now I need to do the same for the rest of the windows. So I will start a loop again. I is equal to k, I smaller than n, I plus plus. Let me take n here. N is equal to nums dot size. Now basically I am going to the remaining windows one by one. So basically by remaining windows, what I mean is I have to insert one element, I have to remove one element, right? So let us see. All right. Now I need to, so let's say in this particular window, let's say all the elements are already there. So let's say this is 5, this is 4, this is 3, and this window size is 3. In this case, first element will be 5, then after that 4 will appear, and because 5 is greater than 4, the 4 is not going to remove 5. Okay?
Right.
4. Then 3 will appear, 3 is not greater than 4, that's why 3 will not remove 4, that's why 3. So this window will be of size 3. Alright, every element will be there inside the window. So, and when I'm putting 2 inside it, so in that case also nothing is being removed. But in front of the window we have 5. But we want to remove 5 because 5 is not the part of this particular window. So from the front, I need to remove those elements which are of no use now. Basically, they are old, right? They are old. They were the part of previous windows, not the current window. So I have to remove those elements, but somehow I need to know that what is the actual difference between the currently inserted element and the element which is at the front. So I had to, for that, instead of keeping nums of I here, I can simply keep I. Okay, I am simply keeping the indices inside this window, not the actual element. And if I have the indexes, I can access the actual element with the help of this nums of I, nums of window dot back. Okay, that's how I can access it. So answer dot pushback window dot front, not window dot front, nums of window dot front. Now going to the remaining windows. If there will be at max only one element, right, which has to be removed, so we can use if condition here only. If window dot size, like if the size of the window is there and window dot front, the first element, if the difference between this and I, so I minus this. Okay, let's say first element is 0, I is k, first element is should be removed. So this is greater than or equal to I or equal to k. So in that case, the first element will be removed. Pop front. All right.
Right.
So after this, yeah, we can do the same procedure. While window dot size and window dot and nums of I is greater than equal to nums of window dot back, window dot pop back. I will do the same procedure. Basically, I am inserting the new number, but when I am inserting the new number, obviously I will remove all those which are of no use.
Right.
In future also and in current window also they are of no use. So those elements will be removed, and again I can do answer dot pushback window dot front after this. One more thing, yeah, I will have to push it. All right. So okay. Finally, I can return the answer from here. Return answer dot pushback nums of window dot front. All right. Okay. So I think
So, uh, do you think you have handled all the corner cases? Do you want to check the code again?
corner cases. So it might be possible that this k itself is greater than the size nums, right? In
Right.
that case, we will not have any windows. So in that case, we simply have to return the answer. So if k is greater than n, right? In that case, we can simply return an empty array as the answer.
Okay.
Apart from that, I think all the corner cases will be handled.
All right. So you can mention the time complexity above your code.
Okay. So the time complexity is big O of n, where n are the number of elements inside nums, and space complexity will be in the worst case big O of k, where k is the size of the window. So we will have actually, we are maintaining the window, right? So that will have at max k elements inside it.
Okay, perfect.
Hmm.
So let's now move to the next question.
Yeah.
So you have to implement a data structure
Mhm.
which inserts an element
Yeah.
in big of one time complexity, removes the element in big of one time complexity,
Okay.
and gives a random number
Mhm.
in big of one time complexity.
All right. And how are we supposed to basically return that random number? So what is the criteria of returning that
So the
random?
probability of getting each number should be equal.
All right, all right. Getting each number which is present inside the data
Right.
structure should be equal. And let's
Yes.
say the number are same. Let's say there are two instances of the same number. Let's say
So
four
you can assume that there are only unique numbers in
unique
that.
numbers,
Yeah.
right? All right. Okay. So basically, insertion and deletion could be very easily be done in a vector. We can insert at the back of the vector in a constant time, and we can remove from the back of the vector in a constant time in big O fun time. Also, we can. Oh, all right. Removal is not big O of one time in vector. It is big O of n time if you are removing it
Right.
from basically
Yeah, if
a
it's not present
place.
in the end, you will
Hmm.
have to traverse the whole vector.
All right. All right. All right. And yeah, if we have a vector, we can generate randoms really quick, right? Randoms would be, let's say if I have a vector and that vector is of size n, basically indices will be from 0 to n minus 1. I can simply generate a random number from 0 to n minus 1, and that random number will be like it will have the same probability for each of the indices. So we can return the value at that random at that particular index.
Okay.
So that is easy to do, but then the deletion, let's say if I've been asked to delete a particular number inside the vector, so that will be kind of tricky. But that could again be done. That could again be done. Let's say if I move this number to the end, and whatever is at the end, if I bring that to the position, like basically I'm swapping it with the ends and then deleting the end. So because I don't have to actually worry about what is the order of the elements inside the array which I'm keeping.
Right.
And one more thing, when you are asking me to delete a particular element, in that case, I will be given the number to be deleted, right?
Right.
So
Yeah.
I have to know that at which particular index this particular number is appearing,
Yeah.
so that I can make these swaps. So for that, we can maintain an unordered map.
Okay.
An unordered map could be maintained, which will have the key value pairs. The key is going to be the number, value is going to be the index on which the number is placed,
Okay.
right? And when we are doing the swaps while deleting, we will make changes to this map. Whenever we are inserting a number, we will make changes to this map, right?
Okay. So your approach looks fine to me. You can code the solution now.
All right, so okay, these are three functions. Let's say we name this class as um, random mm, data structure. Okay. Yeah. So inside this class, I'm basically going to implement these three functions. So let me first take a vector of int elements. Now the first function is basically to insert an element inside this vector. So I'm inserting at the back only, as I told. Insertion at the back is a constant time. So elements dot pushback. Oops. Let me write the name of the function, insert. It will be of the type void, while insert int x. This is the element which I have to insert inside my vector or the data structure. So inserting it at the back. There's one more thing. So basically, yeah, I have to maintain an unordered map as well of type int comma int. So this will be my element map, element index map. So inside this map, I have to basically maintain that this is the element which I am pushing inside my data structure x, and it is pushed at a certain index, right? So element index map of the element x is basically equal to, and because the elements which we are inserting inside this particular data structure are unique, so we can keep them as the key of the unordered map. We don't have to worry about it because these are always unique. So this is equal to elements dot size. Okay, and they are pushing it back. So basically, if the size in the index in which I'm keeping this particular element is will be n minus 1, right? So that's why I'm just taking the size here itself when it was n minus 1. Now the size is obviously increased. So this was my insert operation. Similarly, we will have a delete operation. Void delete element. So we are going to remove this particular element x. Yeah. So to remove this element, I will have to swap it with the element which is at the back. All right. So the element which is at the back, I okay, put it there and shift this element to that particular place. And then we will have to change the entries inside the map accordingly. Okay. So um element index map of the element which is at the back is going to now change. Okay. So elements dot back will be equal to element index map, basically the index of the current element, right?
Right.
The last element is now going to shift here. So when it's shifted here, this is changed. Inside the vector also I need to make the swap. Element of okay, so let me take the indices here itself. Int index of the element, index x. Okay, index x is equal to this one. We will get the index with the help of the map which we are maintaining. Now int index y, this is the element which is at the back, so this is equal to elements dot size minus 1. Okay, now we have both the indices and we can simply swap them. Swap elements of index x comma elements of index y. Okay, so this is the swap. Now I need to make changes in the entry of the map. So this is equal to, yeah, this is equal to the index x. Element map. All right. So I think, yeah, now finally after this I need to remove that element from the back. So elements dot pop back. Yeah. So this way basically we will be removing the last element, and we don't have to worry about the map entry of the element which we are removing, because nobody is going to ask for that. Okay, nobody is going to ask for that particular element, and in future let's say if this element appears again, this value will be overridden, so we don't have to worry about it. So now there's one last function left, that is to return the int random number. So this will be, so we already know that what's the size of the data structure that we are having. So int n is equal to elements dot size. Now we have this n and we can generate a random number between 0 and n minus 1. So int random number is equal to random modulo n. So this will generate a random number between 0 to n minus 1. And we can return elements. Yeah, we can return elements of this random number. All right, so elements, okay, so I think this is it. All these three functions are running in constant time.
Okay, so yeah, the code looks fine to me.
Okay,
So we are done with the interview. Thank you so much for your time.
thank you. All right guys, so thanks a lot for watching till the end. I was able to come up with the solution to both the problems, in the very first go, basically those were kind of medium problems, and yes, those were not very difficult to come up with. But then the interviewer pointed out that there should be consistency in the way we are writing the code. There should be spacing and indentations. And one more thing, I am very bad with variable namings, so make sure that you improve yourself upon that as well, because variable namings also matters a lot. It matters a lot that you name the variable in a meaningful way. So these were the feedbacks by the interviewer, and yeah, it took me very less time to come up with both the solutions. So guys, if you're new here, subscribe to the channel. If you love this video, make sure that you give this video a thumbs up, and make sure that you comment down below that how are these videos helping you. Also guys, I have provided the link of Hirect app in the description. You can go and download it and अपना career hike करके तो देखो.